Today we're going to look at some of the more complex properties of logarithms. And I'm going to start with something called change of base. Change of base does exactly what it says it's going to do. It lets you change the base of a log. So for example, if you have a log base 7 in your problem and you think, I don't want log base 7, I want log base 2 or log base 10 or whatever, you can do that. You can change the base of a log to absolutely anything you want with this formula right here. So what you have your original log, we'll call it log base b of x, and you can change it to log base a, and I used a for anything. A stands for any number you want. So I can change it to any log I want, but it actually turns into two logs. It's a fraction or a division problem. So what you get, once you decide what base you're using, you get the log of this number on top, whatever it is, and the log of the base on the bottom. So it's always log of the second number, or the physically bigger number, goes on top, and the log of the base goes on bottom. And you can use any new base you want. The log of the original base goes on the bottom. Okay. Now, the most common use for this is so that we can use calculators. So remember, on logarithm day 1, we said the only button most calculators have is either log, which is common log base 10, or ln, which is natural log. So what you have, if you have some other log and you want to approximate it, if you use change of base formula and you change it to one of those two things, either base 10 or base e, natural log or common log, then you can use a calculator to evaluate. Now, I do want to mention this is not the only use for change of base. You know, a lot of times people think, yeah, that's all we use this for. I'm going to show you some examples a little later in the year, especially when we get to derivatives, where you can use change of base to actually make your questions a lot easier. But for right now, let's go back to the very first question I asked you when we were talking about logs. I said, when we were talking about just what a logarithm is, I said logarithms answer the question like 2 to what power equals 75. We'll write it down over here. We have 2 to what power equals 75. Now the answer to that question is the log base 2 of 75, because that's what log base 2 of 75 means. And we said at that point in time, we still didn't really know what to do with it. We did know, and we talked about this in day 1 of the notes, we did know our answers between 6 and 7. Because 2 to the 6th power is 64, and 2 to the 7th power is 128, 75 somewhere in the middle there. But what we want to do is we want to use change of base to figure out more accurately, it's still an approximation, but to figure out more accurately what that number is. So I did something like this. I took my log base 2 of 75, and I said, let's just change it to common log, log base 10. So I did the log of this number, 75, over the log of this number, 2. And I did it on a calculator. I used divided by. I just grabbed a calculator and typed log of 75 divided by log of 2. The answer comes out to 6.23, about. I rounded off to 2 decimal places. But yeah, I mean, it is between 6 and 7. We are right. So now all of a sudden we have a way to use calculators to more accurately answer that question. So the answer to the question, 2 to what power equals 75, if you round it off to 2 decimal places, it's about 6.23. Now before we move on, I just want to mention I chose log, but I also could have done natural log. So I could have done this. I could have said, okay, instead of using the common log or base 10, let's change to base e, the natural log. So I did, same thing, natural log of this number on top over natural log of this number on bottom. I grabbed my calculator, I used the ln button instead of the log button, and I did natural log of 75 divided by natural log of 2, you get the exact same answer. So it doesn't matter which button you use, log or natural log. Like you can't mix them up. You can't do log of 75 divided by natural log of 2. That wouldn't work. Pick one and go with it. But either one should work. So if you do change of base and you change to either log or natural log, then you can use your calculator to now approximate any log. Okay, so that was change of base. let's talk about some more properties. So we have these three properties that go together because they're very often used in the same problems. Here's our first one. It's for taking the log of a product. So instead of the log base b of just x, one thing, it's the log base b of, we call it uv for the notes, but it's two things multiplied together. Could be simple like 5x, could be complicated like, you know, x squared plus 3x plus 5 times 10x squared minus 11x plus 9 or something, you know, two things in parentheses. Any two things multiplied together that you're taking the log of. Basically, you can split it apart. You get two separate logs with the same base. So remember, because I had a base here, base b here, you're always going to keep the same base everywhere when you do this. But basically, you split the product apart, and you turn it into an addition problem. It ends up you're adding the two logs together. So like I said, it could be as simple as log base 2 of 5x. You could just split the 5x apart and turn it into two separate logs. It's base 2, we're going to keep the base, and you add them together. So it would be log base 2 of 5 plus log base 2 of x. That is a 2 right there. I started to write a 5. One thing to remember, either of these properties, any of these properties we're about to talk about work forwards and backwards. So I could also, if I had some problem where I had this in a question, log base 2 of 5 plus log base 2 of x, I could combine it into one single log, base 2, and then multiply the 5 and the x. It also works with just numbers. So like, let's say I had log base 2 of 10. You think, well, that's not a product. That's just one number, that's 10. Well, if you wanted to, if you needed to for whatever reason in your problem, you could say, well, 10 is actually 2 times 5. And then you could break it into log base 2 of 2 plus log base 2 of 5. If you wanted to for whatever reason. You can break numbers apart like that. You can break a 5x apart like that. Any product, any two things that are multiplied together can be broken apart. And then, of course, it works backwards too. So just like I said before, if you had this in a problem and you think, well, I have these two logs, they're both base 2. I don't want two separate ones. Let's just combine it into one. And then you turn it back into this. Okay, second property is very similar. It just has its inverses. So this is a quotient instead of a product. So we have the log of, instead of u times v, we have u over v, or u divided by v. And because that's the inverse of multiplication, we get the inverse right here also. We get minus instead of plus. So very, very simple, very similar concept. If you have the log of two things being divided, you can break it apart into two logs, same base. Log of the top minus log of the bottom. And again, I'll give you an example, a quick example with a number in it. Let's say you had the log base 5 of 2/3. We'll just do a number. And you go, all right, well, you know, I don't really like having fractions in there. If I wanted to, for whatever reason, I could change it into the log base 5. Remember, you're always going to keep your base on these questions. Log base 5 of the top, 2, minus log base 5 of the bottom, 3. And then same thing I said before, works forwards or backwards. You can start with the 2/3 and break it apart, or you can start with the two separate logs and combine them into one. Okay, our third property here has to do with exponents. So let's say you have log base b of u to the n power. It ends up equaling n times log base b of u. Or the way I like to think of it is you can take that exponent and drag it out front and turn it into a coefficient. Now, just so you understand where this property comes from, this is actually an extension of the property number 1 of multiplying. Because if you think about it, if I have the log base b of u squared, another way to think of that is log base b of u times u. And then if you use your adding property, that would be the log base b of u plus the log base b of u again. And when you have two of the same thing, you just add them together. You have two of them. You have 2 log base b of u. So what we're doing is this 2 tells you how many u's are being multiplied, which basically when you break it apart tells you how many are being added and gives you the constant out front. So it's basically, like I said, it's an extension of the multiplying rule. If I had log base b of u to the 5th power, and I wrote it as u plus u plus u plus u plus u, or times first, 5 of them, and then I broke it apart like this, and turned it into 5 different logs being added together, it would be 5 log base b of u. All right. So let's do an example, and I'm actually going to work this one out a few different ways. We're going to evaluate log base 25 of 125 without using a calculator. Now the question, if you think back to the first way we talk about logs, I'm asking you guys 25 to what power equals 125? Now that's not really one I can answer in my head. It's not like an even power. 25 to the first is 25, and 25 squared is 625. So it's not really one you can just say, oh yeah, I know the answer to this. But we're going to use our properties to break it down, and I'm going to show you a couple different ways to do it. Maybe even a few different ways. So let's do this. Let me start off with the way I showed you with property 1. I'm going to rewrite this question as, instead of 125, I'm going to say, well, 125 is actually 25 times 5. And now I can use my u times v property. I can break it up. So I can have the log base 25 of 25 plus the log base 25 of 5. Now each one of these I actually can answer. The second one's a little trickier. The first one is asking me 25 to what power is 25? The answer to that question is 1. The second one is asking me 25 to what power equals 5? Now that one's a little trickier, but we want to realize that the square root of 25 is 5. And a square root is a 1/2 power. So 25 to the 1/2 power equals 5. So we have the log base 25 of 5, which is 1/2. So the answer to the question, I get a 1 from the first part, a 1/2 from the second part, add them together, you get 3/2, or 1.5. So the answer to the question is 3/2. That was kind of confusing. We broke it apart, we had to use our u plus v, that was a little tricky, plus we have the log base 25 of 5 in there, which again isn't even that easy. Let's see if we can figure out an even easier way. Let's think of some of our other properties here. So let me start the question again. Here's a good way. In fact, I think this might even be the best way. I look at the numbers in this question and I say, well, I have a 25 and a 125. Those are both powers of 5. 25 is 5 squared, 125 is 5 to the 3rd power. So I said this question would be a lot better if it was log base 5. And then I think of the very first thing we talked about, change of base. I can do that if I want to. So I'm going to change this question. I'm going to do the log base 25 of 125 equals, and I'm going to use my change of base formula. I'm going to change it to base 5, and I'm going to do the log of this number on top, and the log of this number on bottom. So remember I told you, change of base isn't only for calculators. Now all of a sudden, the top is saying 5 to what power equals 125, and the answer is 3. And the bottom is saying 5 to what power is 25, the answer is 2. We get the same answer, 3/2. I think that way was much easier. There actually are other ways to do it. You can kind of manipulate it and use the u minus v rule. Let me show you one more way. I told you I want to show you three. So we have log base 25 of 125, and let's say I realize that 125 is actually 5 cubed. Then I can use my exponent rule. I can pull that 3 out front. And I say, well, that's 3 times log base 25 of 5, which would be 3 times, and we already realized from a question earlier, the log base 25 of 5 is 1/2 because it's a square root. So you get 3 times 1/2, which equals 3 over 2. So we got the same answer 3 totally different ways, and that's really what I want you guys to take from this example, is that when you're working with logs, there are very, very often more than one way to do a question. You can think about it this way, you can think about it that way, you can do it this way. There's a lot of overlap and a lot of things that are kind of the same but a little bit different. So don't be afraid to try different things. You might find one way that's a lot easier. I personally think the easiest for this one was change a base. Change it to base 5. I think that was quickest and easiest. But the other two ways got us the right answer, and there's nothing wrong with that.